The first question in the homework asked us to factor 4n squared minus 17n plus 4. Our first step here, of course, is to multiply a by c. That gives us 16. Factor pairs of 16 include 1, 16, 2, 8, and 4, 4. Now we're looking for a factor pair that could ever add to negative 17, so that's going to give us 1 and 16. Now, a very helpful tip that we're going to see be useful going forward is that when you have a positive product, and we know that when the product of two numbers is positive, that means that the two numbers had the same sign. So either both of these numbers were positive or both of these numbers were negative. We see they have to add to a negative number, which tells us that these two numbers had to have been both negative. So we're going to take these numbers and we're going to split this equation. And so we're going to say 4n squared minus 1n minus 16n plus 4. Now the order of these could be different. It could be 16 first and 1 second. It doesn't make a difference in the end. We're going to see that in today's lesson. So when we do this, we split it down the middle. We say 4n squared minus 1n. The GCF there is n. That leaves us with 4n minus 1 on both sides, and then n minus 4 on the outside. So our final answer is 4n minus 1 times n minus 4. And I've checked my work here. You should do that on your homework as well. Number 2 says 2n squared plus 5n plus 2. 2 times 2, a times c, is 4. That gives us 1 times 4, 2 times 2. Again, this is positive, which means they have the same sign. They add to a positive 5, which means that both of these numbers are positive, which means we could say plus 1 plus 4. We could have also said plus 4 plus 1. It gives us the same result, although the middle step would be different. We're going to see that again in today's lesson. So we split this down the middle. We say, well, the GCF here is n, so it's 2n plus 1 on both sides. N plus 2 is our remaining portion. So this is 2n plus 1 times n plus 2. And you check your work, you find that is correct. Number 3, we multiply a by c. Now this gives us a negative product. This is the first one in the homework where we see that. And that means that the numbers we choose have to have opposite signs. Now it doesn't tell us which number should be positive and which number should be negative. However, we can figure that out. So this number that we get is negative 100, this guide number. So negative 100 is one of these factor pairs. It's going to be 5 times 20. Now that would be 5 plus 20 is positive 25. So they can't be both positive. If the 5 were negative, that would be positive 15. So we need the 20 to be negative. So it's negative 20, positive 5, and that adds to negative 15. Now again, these numbers could be switched. You get the same result in the end. So we're going to split this down the middle. The GCF of the left side is 4n. Then we have n minus 5. So if it's n minus 5 here, then we have to factor out a positive 5. So our finished answer here is going to be n minus 5 times 4n plus 5. And of course, that could have been 4n plus 5 times n minus 5. You could have switched these two. The order really doesn't matter when we're talking about multiplication and addition. All right, number 4 says 7a squared plus 53a plus 28. 7 times 28 is 196, so 1 times 196, 298, etc., etc. It turns out that 4 and 49 are going to give us a sum of positive 53. They are the same sign because this was a positive 196. So we split this and we say that it's 4 and 49. When we factor out from the left side of GCF, we see it's a. So a times 7a plus 4 plus 7 times 7a plus 4. And when we factor out the GCF of 7a plus 4, we get 7a plus 4 times a plus 7. And that's going to be our answer. Number 5. Now, number 5, I wrote this out without acknowledging that there was a GCF. There is a GCF of 3 here. All of these terms are divisible by 3. So if you factored out a 3 first, this would actually be easier because the factor number, the a times c, this magic number on the side, is 189, which is a real number, but is kind of annoying. If you were to factor out a 3, that would have been 3 times 7, and this just would have been 21. So it's probably easier, although it gets you the same answer in the end. So using 189, which I saw most of you did in the homework, which again is fine. It's just easier if we factor out GCF. But 3 times 63 is going to give us that 66. Well, 3 plus 63 is 66, but 3 times 63 is 189. So we factor this out. We split this up to be 3 and 63. Then we factor out from the left side 3k. So it's 3k times 3k plus 1. And here we factor out 21 to get 3k plus 1. Simple enough. When we do that, we get 3k plus 1 times 3k plus 21. A lot of you wrote this as your final answer. This is actually not completely factored because the first binomial is fine, but the second binomial has a GCF of 3. Both of these terms are divisible by 3. So we could factor out one step further, and this in the box is going to be your answer. 3 times 3k plus 1 times k plus 7. Of course, these two binomials could be switched. This k plus 7 could be first. The order doesn't really matter. But this technically is the final answer. So we're always on the lookout for a GCF. All right, number 6. Number 6 was 4 terms, so we don't have to do a times c. We actually should not do a times c. We're just going to split it right from the problem. This goes back to the previous lesson. So the GCF at the left side is 4v squared. That leaves us with 7v plus 4. If that's on the left, it has to be on the right. So 7v plus 4, well, you'd factor out a negative 3 if you were going to do that. So our finished answer is going to be 7v plus 4 times 4v squared minus 3. In lesson 8, we're looking still at factoring trinomials by grouping. We're going to continue with this skill. We're going to add on to our skills a little bit here. So our first example here, again, please have a notebook out, write these examples down, try them as I try them. You might even want to skip ahead, pause, see what I do after. That would really be the best way to do this so that you're learning and you're not just watching. It's very important that you're able to do this on your own. So 3x squared minus 2x minus 8 is our problem. I've written out the first step here, 3 times 8, and 3 times negative 8 rather, which gives us a negative 24 as our product, and write out all the factor pairs of 24. So I'll give you a second to pause and to do that. All right, so if you've done that, you will see that the factor pairs of negative 24 are 1 times 24, I'm going to write them over here because I didn't leave space, 2 times 12, 3 times 8, and 4 times 6. If you continue to 6 times 4, that's the same thing, so we stop. So out of these factor pairs, what could give us a sum of negative 2? Well, that would be 6 and 4. Now, 6 plus 4 is 10, so that's not going to be straight out. It's going to be negative 6 and positive 4. Now, I said in the homework review that this sign here is very important. This tells us that, since it's negative, the two numbers we choose have to have opposite signs. So it can't be positive 4, positive 6, or negative 4, negative 6. It has to be a mix. So I've written out 2 columns here, and I've actually done that for all the problems on the page because I want to show that we can do this in 2 ways, which we didn't address last time. We kind of briefly touched on in the homework review, but I'm going to write this as minus 6x plus 4x. Now, the other way we could do this would be if the 4 were first and the negative 6 were second. They get us the same result, but since the numbers are connected via addition, even though this one is negative, we're really adding a negative. Since they're connected via addition, we can use the commutative property here. So let's look at the left side and we'll complete that first. So 3x squared minus 6x, the GCF there is going to be 3x. We factor out 3x, we get x minus 2. On the right side, we also have x minus 2, but that means we have to factor out a positive 4. So when we look at this, the GCF there is x minus 2, and then the remaining portion is 3x plus 4, and that's going to be our answer. Now we should be getting the same answer on the right side, just a different step in the middle. So let's split this down the middle. And the GCF of the left side here is x. That leaves us with 3x plus 4. Then here we have to have 3x plus 4. And what gets us there? Well, negative 6 becomes a positive 3 if you factor out a negative 2. So our final answer here, this is our GCF, is 3x plus 4 times x minus 2, which is the same answer, just written backwards. And again, commutative property says that's okay. Okay, so I really wanted to show that for us today. So our second example here, take a moment, copy that down, try it. Try it both ways if you want to really challenge yourself. Make sure that you know this process inside and out. So take a moment, pause the video, give that a try. All right, I've written out the factor pairs of 42 here. So the factor pair that we're looking for has to add to 17, and this is a positive 42, which means that the two numbers have to have the same sign. Either they're both positive or they're both negative. And since they add to a positive, they have to be both positive. So which two numbers here could add to positive 17? That's going to give us 3 and 14. So we're going to say that this is plus 3x plus 14x. But we could have also said that this was plus 14x plus 3x. They will give us the same answer. So let's look at the left side first. We split this. We see the GCF of the left side here is x, and that leaves us with 2x plus 3. That has to appear on the right side, so 2x plus 3, 14 to a 2 means we factored out a 7. Our GCF here is 2x plus 3, so our final answer is 2x plus 3 times x plus 7. Now we should get the same thing on the right side. Let's give that a try. GCF here is going to be 2x. That leaves us with x plus 7. X plus 7 factored out here means we factored out a 3. So x plus 7 is the GCF, and 2x plus 3 is the remaining portion. And again, these are the same answers written backwards. Commutative property allows that. Okay, so let's have a look at our second part here, factoring trinomials when there's a GCF by grouping. Okay, so we're going to look at this, and we see that there's not immediately apparent a GCF. 3, 5, and 2 are actually all prime numbers. However, the GCF here is going to be x. This is x cubed, x squared, and x. All three terms have x. So we're going to factor that out first, because we can't actually do this if this is x cubed, x squared, and x to the first. This has to be a constant, and this has to be squared for this method to really get off the ground. So we're going to factor out x. That's going to leave us with 3x squared minus 5x plus 2. Okay, so we're going to try this two different ways. The x in the front actually stays where it is. We're going to say 3x squared blank space plus 2. And on the right side, we're going to try the same thing, 3x squared blank space plus 2. However, we actually have to find the factor pair. So 3 times 2 is going to be 6, which is 1 times 6, or 2 times 3. Now we're adding to negative 5, but we multiplied to a positive 6. And this is when knowing that this is a positive number, meaning they have to have the same sign, is very important. If they had the same sign and we chose 1 and 6, that would either be both positive, 1 plus 6 is 7, but we're looking for negative 5, so it couldn't be that. If they're both negative, then that would be negative 1 and negative 6, which would be negative 7, but we're looking for negative 5. So even though 6 minus 1 is 5, that actually doesn't help us here because we need the same signs. So it has to be 2 and 3. And when we use this, we're going to find that it's negative 2 and negative 3. They have to have the same sign, and it gives us negative 5. So this is going to be minus 2x minus 3x. And on the right side, we could do minus 3x minus 2x. Now I'm showing you both ways of doing this because it is possible to do it two different ways. You do not have to do it both ways when you do this work. It gives you the same answer. So as long as you're doing it one of these ways, you're okay. So on the left side here, the x remains in place. The GCF of the left here is going to be x. That leaves us with 3x minus 2. 3x minus 2 is over here, which means we factored out a negative 1. And so our finished product, our finished factorization, is going to be 3x minus 2, x minus 1 with an x in the front. Okay, now we're going to try it on the right side. The GCF here is 3x, which leaves us with x minus 1. X minus 1 was here, which means we factored out a negative 2. Okay, when we put that all together, we're going to get x minus 1, 3x minus 2, and that is the same answer that we got the first time. X times 3x minus 2, x minus 1. All right, let's focus our attention on this example up here. I encourage you to pause the video here. Try this. There is a GCF. Try to factor it out first. All right, our GCF here is 4n squared. So we see n to the fourth, n to the third, n to the second. We don't want all of that. We just want it to be n squared, n, and then no variable at all. So we also see that these are all multiples of 4, so we're going to factor out 4. We end up with 4n squared times 7n squared plus 4n minus 20. So now that we have this GCF factored out, we're going to multiply 7 by negative 20 and get negative 140. Now this is negative, which means that the two numbers have different signs. They have to have opposite signs. So there's a lot of factor pairs of 140. So 1 times 140, 2 times 70, 4 times 35, 5 times 28, 7 times 20, and 10 times 14. Now we're looking for a factor pair that opposite signs adds to a positive 4. The only factor pair here that's going to give us that is 10 and 14. 14 positive and 10 negative would subtract to give us a positive 4. All these other numbers are too far away. This would be either 13 or 27. This is 23 or 32, 33. 33. Either way, they're too far. We need the number 4. So we're going to take this, and we're going to say this is 4n squared times 7n squared plus blank space minus 20. So it's 10 and 14. And we're saying that this is plus 14n minus 10n minus 20. Now I'm just going to do this the one way because I didn't really leave enough space here, but you could imagine that this would be the same if you switch the numbers and 10 was first and 14 was second. Gets you the same result. So the 4n squared is going to carry down with us here. We're going to say this is, the GCF of this is 7n. So we factor out 7n, we get n plus 2 on the left, which means it also has to appear on the right. Well, how do we go from a negative 10 to a positive 1? We factored out negative 10. And we always want to double check that this number here also divided by negative 10, because if it didn't, we probably have done something wrong and we need to go back. All right, so n plus 2 is the GCF here, so it's a 4n squared, again, carries down. N plus 2 is our first, and 7n minus 10 is our second, and this is going to be our finished answer. Now, you might look at this and say, well, isn't there one more step? It looks like there might be because there's numbers here, but 7 and 10 have a GCF of 1, so that's not really going to help us at all. This is our final answer. All right, if you did it the other way, you'd probably get 4n squared times 7n minus 10 times n plus 2. Same thing, just written in a different order. All right, last one for today. Copy this down, give it a try. There is a GCF. That is the letter X. I made a mistake writing that down. I wrote N. Okay, we're looking for a GCF. We see all these numbers are even, 12, 10, and 12. So we're actually going to factor out a 2. That's the GCF. But also x to the fourth, x to the third, x to the second. It's the same as the previous example. We're going to factor out x squared. So 2x squared is our GCF. That leaves us with 6x squared plus 5x minus 6. We're going to multiply 6 times negative 6 and get negative 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Now we're looking for a factor pair that could ever give us positive 5 as a sum, but the numbers have to have opposite signs because this product is negative. So looking for opposite signs with a sum of 5, that's going to be 4 and 9. Positive 9, negative 4 gives us a sum of positive 5. So 2x squared stays, 6x squared blank space minus 6. The two blank spaces are going to be positive 9x and negative 4x. And then we split that down the middle and do what we've always done. So 2x squared, 6, I don't want to write that now. I want to factor out the GCF, which would be 3x. When I do that, I'm left with 2x plus 3. And on the right side, 2x plus 3. But how did I get from positive 4 to, negative 4 to a positive 2 and a negative 6 to a positive 3? We factored out a negative 2. So we're going to say 2x squared again. The GCF here is 2x plus 3. And 3x minus 2 are the remaining portions. So this is going to be our final answer. There is no further factoring. There's no GCF in these terms. This is going to be the answer. In the last video, we had this as part of our homework review, and as I was recording it, it didn't actually finish, and I just put up the answer. So I want to go over this one more time to show you the process because it can be a little confusing. Okay, so this is the problem. This is the problem as it was given. And so we see that this has a lot of different variables. They're in all kind of wacky positions. One thing we want to notice is that this term at the beginning and this term at the end have the variable c. And these two terms in the middle have the variable d. So we should rearrange this so that we can get, a common factor between terms that are near each other. So I'm going to move this term at the end right here to the middle. So I'm going to rewrite this as 16x squared c. Then I'm moving this here. So minus 8xyc plus 8xyd minus 16x squared d. Now, one other thing that I want you to notice is that it's 16, negative 8, positive 8, negative 16. So we might want to rewrite this again so that it's 16, 8, 16, 8. And we don't have to do that, but it would probably be easier if we did. And again, this is all commutative property. We can simply move things around when they're added and subtracted in a polynomial. So I'm going to write this as 16x squared c minus 8xyc. Then I'm going to put the 16 here first, so minus 16x squared d plus 8xyd. Now this seems like a lot of prep work, but it actually is going to make a huge difference for us when we go to finish. So this is 4 terms. We can actually just split this down the middle right now. And on the left side, we see that 16x squared c and negative 8xyc, well, they have c in common. They have x to the first power in common, and they both have 8 in common. So if we factored out 8xc, what that would leave us with is 2x minus 1, that cancels, minus y, 2x minus y. So if 2x minus y is on the left side, then that means 2x minus y has to be on the right side. And how did we go from this to that? Well, let's look at what's missing. Negative 16 became a positive 2, which means that we factored out a negative 8. Correct. And then x squared became x, which means we factored out x. And then d disappeared, which means we factored out d. Now, if we look at this, we want to make sure that this also works with that same scheme. So positive 8 became positive 2. Oh, sorry. Positive 8 became negative 1 by factoring out negative 8. Fine. X disappeared. Okay. And d disappeared. Okay. So then we factored out negative 8xd to get negative 1y. All right, so negative 2x minus y is our GCF, and then 8xc minus 8xd is our other term. Now, just like we saw in other examples since then, this term here has a GCF, and these two, this binomial here has a GCF, and 8x appears in both. So we could factor out 8x. That would leave us with c minus d, but then we also have to have this first piece here, so we could write this whole thing as 8x times 2x minus y times c minus d. Now, if you went back to the very start of the entire thing, you could see that 16, 8, 16, 8. Obviously, there's a GCF of 8. Then we see x, 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 x. X appears in all four, so we could factor out x. So 8x is the GCF of all these terms. And when you look down here, what was our first piece? 8x. This is our GCF piece. Now, the work that I've done here doesn't actually involve factoring out a GCF until the last step. It probably would have been easier if we factored out at the beginning, but it's the same problem with the same answer.